Hey everybody, so we are going to move on and do some more rational functions. So this is the parent function, or I like to say the mother function. Do a quick sketch of it. So this has a horizontal asymptote at 0, right? This thing will never equal 0. If you plug in a really big number, 1 over a billion, you get 0. And a vertical asymptote also at 0. Right? If you try to plug 0 into that function, you are going to get 1 over 0, which is undefined. All right, so it's just this curve, right? That's what, and this is pretty much whatever every rational function looks like. It's just kind of slightly moved, just like all other parent functions. All right, so remember, a rational function is a function that is a fraction with a variable in the denominator. So 1 over x is rational. X over 2 is not, right? That's a line. That's just 1/2 x. So this is not a rational function. The x has to be in the denominator. All right, a vertical asymptote. Let's just write down how to find it. We set the denominator equal to 0. A vertical asymptote, right, is a vertical line that the graph does not typically cross. It can, but it's rare. And then the horizontal is the end behavior, right? What does the function equal? What does f of x approximate when a very large number is plugged in? All right, so horizontal. So it's what's happening to the y values as the numbers get really, really big or really, really small. All right, I want you to pause the video. This is what we did Monday's lesson. All right, so I always start with my vertical asymptote. So that's just x equals 3. Right? I'm setting my denominator equal to 0. The horizontal asymptote, the original function, that goes to 0 plus 5, so y equals 5. And please remember that these are equations, so that's why I put the x equals. X equals 3 is a vertical line. Y equals 5 is a horizontal line. 1, 2, 3, 4, 5. So again, I know approximately what this thing is going to look like that, but I want a nice picture of it. We're not going to go crazy with it, but I like to have a couple points so I can be semi-accurate. If it says sketch, you don't have to be as accurate, but that's why I just want to practice actually graphing. So what we do is we're going to find 4 points. I start with what will make the denominator 1. So if I plug in 4, that gives me 8 over 1 plus 5. Oops. Ugh, 13. That's annoying. Let's see. And then what would make the denominator, what would make it 8 over 8? So that is 11. So if I plug in 11, that gives me 6. And then what will give me negative 1 on the bottom? 8 over negative 1 plus 5. Negative 1, that's a 2. Right? I plug in 2, I get negative 1 on the bottom, and that gives me negative 3. And then what will give me negative 8 on the bottom that would be -5. So that gives me 4. So those are the points I'm going to plot. Make them blue. All right, so 413, yeah, it's off, but that's okay. 11, 6. 11, 6. I'm jealous of people who are good at drawing on these tablets. All right, 2, -3. And -5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So these have a pretty good, like they're not super close because of the 8. The bigger the number on top is, the farther away it's going to be. So that looks pretty good. That's it. Fix that. All right. So apparently we have the same number twice. Moving on. All right, before we start this next one, I want to see who is actually listening to my videos and who is just copying. I want you to draw a happy face. Make it fun looking, and when I check your notes for this assignment, I'm going to look for your happy face. And if you don't have a happy face, I'm going to take 2 points off your notes. So draw a happy face right before problem number 3, and we will see what happens. All right, this process is the same. You'll see what's going to happen, and a reason that I like to find the points. So I have my vertical asymptote. X equals -4, what makes the bottom 0. Horizontal asymptote, y equals 0. There's no plus number, no x's on top. So x equals -4. 1, 2, 3, 4. Use a highlighter for the 0 so you can really see it. Okay. So now we're going to plug in what will give me 1 on the bottom, -3 over 1. If I plug in -3, I get 1, which gives me -3. If I plug in -5, right? If I plug in -5, I also get -3 because -1 squared. And then what will give me a 3 on the bottom? -3 over 3 and -1. Right, -1, nope, just kidding. I can't get 3 on the bottom because I'm squaring it. That will give me, if I plug in -1, I get -3 over 9, so that's -1/3. We can do that. That's okay. And then let's pick another point. So I can't get -3. So let's just pick a point. It doesn't actually matter what it is. Let me plot what I have so far. So I have -3, 1, 2, 3, -3, 1, 2, 3. And then I have -1, -1/3. So it's like there. So there's my graph. So I have 1 to the left. I have the -5, -3. I'm going to do like -6. Let's see what happens. If I plug in -6, that gives me -3 over +4. So we have -5, -3, -6 1/4, 3/4. So notice what happened with this one. It's kind of weird to look at. So when it's squared, they were both down here. They're both down there because of the negative. So they're next to, instead of being like on diagonals from each other, when it's squared, they're next to each other. All right, pause the video. Try this one on your own. So I have my vertical asymptote at 5, x equals 5. My horizontal asymptote at -2. And 5, 1, 2, 3, 4, 5. So some of these, because with the squares and everything, it is hard to come up with nice points. So we are kind of estimating, but that's okay. All right, so I'm going to plug in 6. If I plug in 6, I get negative 1 over 1 minus 2, so it's negative 3. And then if I plug in 4, I get the same thing, negative 3. So 6, negative 3, 4, negative 3. So we could just plug in 7. Let's see, if I plug in 7, that gives me negative 1 over 4 minus 2, so negative 2.25. So we have to estimate sometimes, but that's okay. So we're like there. That 1 is there, so it's pretty, these are pretty, I should have changed colors. And then if I plug in 3, I get the same exact thing. 2, 5, like there. So it's very similar to that last one. There's a 1 on top, so those points are really close together. All right. Try this one on your own. All right, so this one's harder, right? Because we have 2 vertical asymptotes. X equals 1 and x equals negative 5. Horizontal asymptote, y equals 0. Positive 1. Negative 5. 1, 2, 3, 4, 5. All right, so this one's going to be a little different because notice instead of having just 4 regions, we have 6 regions. So here's what we're going to do. We're going to pick points on either side of both of the asymptotes. So I have my 1, right, my vertical asymptote 1. So I'm going to try 2, and I'm going to look at 0. Right? So if I plug in 2, these are not going to be nice. So I get 3 over 1 times 7, so 3 over 7. If I plug in 0, I get 3 over negative 1 times 5, negative 3/5. So I've got 2 3/7, so 2 and then just up like a half. I keep forgetting to change the color. I'm going to do black. And then 0, negative 3/5. So I have that point. So I know this is going to look like this. Right? But we're not sure what's happening in that middle piece. So now we're going to do points close to the negative 5. So let's try negative 4. And we're going to try negative 4 and negative 6. So let's see what we get. 3 over negative 5 times 1. Negative 3/5 again. And then if we plug in negative 6, we get negative 7 times negative 1, which is 3 over 7. So negative 4, negative 3/5, and negative 6, 3/7. So now what this looks like is over here we have this, and then down in this section, it's going to kind of look like a parabola. It's pretty, because remember that the graph gets really close to the asymptotes, but it doesn't touch it. So what this is going to look like is that. And I know I drew it so it looks kind of vertical, but it's not. So that's typically what these look like when there's multiple asymptotes. There's the curve like normal, and then one piece that looks almost similar to a parabola. All right, last one. Pause the video, try it on your own. So we're going to start by factoring. X minus 5, x plus 2. So my vertical asymptote is at 5 and -2. And my horizontal asymptote is at y = 1. All right, so I'm going to use the highlighter for this one. So I have +5, 1, 2, 3, 4, 5, doot, doot, doot. I wish I could make it skinnier, but oh well. +5, -2, and 1. All right, so now I'm going to plug in numbers around each of the asymptotes to figure out where this curve is going to be. So I'm going to start with 6. We're going to do 6. We're going to do 4. That's either side of the 5. And then I'm going to do -1 and -3. So those are my 4 points I'm plugging in. So -2 over, let's see, I got 1 times 8 plus 1. So that's 1 minus 1/4. So that's 3/4. Then I'm going to plug in 4. So -2 over -1 times 6 plus 1. So that's 1/3 plus 1. So 4/3. I plug in -1. Let's see what I get there. -2 over -1 gives me -6 times 1. So that's 1/3 plus 1. So it's 4/3 again. And then -3, that gives me -8 times -1. So that's our 3/4 again. So then I'm going to plot those. So 6 3/4, 4 4/3, that's a little bit above, -1 4/3, -3 3/4. So that just gives me an idea where this thing is going to be. So we get really close to the graph, but it doesn't quite touch it. That's kind of ugly. I'm sorry. All right, that's it. Practice. Have a great day.